It is time again for the auction included. Let's punch in the play into the main menu here and then resume the game. Good. So just trying to find out some techniques that will help us in survival. And there is the dog. Alright. I think I changed my mind about the saltwater guys here. But before I really changed my mind... I had to reload the game in order to find out about the waterfall. Good. 100 key saltwater. Makes a ton of sense. And we're filling up. Good. We're going to click on a metal tile here. Press Ctrl F4 for the instant build. And do this here. And then we're also going to sample some of this. And brush it in. Good, how much is this? Apparently not enough. Apparently enough. Good. Now we have production, liquid. 10, 12, oh yeah, this is going quick. As nice as this is, having this in the rocket, it's overkill. We don't need that much. Why do we have full pipes here? We don't. Good. Let's repair the pipes here. We have to be more careful when we do this in survival. Good. Alright. And we can stop, I think. The temperature is absolutely nominal. That means no more need for this valve. We deconstruct. And let it all pour out. And then call it good. What is this? Because we cannot see? Don't care. Are you in the interior? Yeah, this will accumulate. Is a regular terraformer. Beautiful. But yeah, I think if we have something like this, might be a good idea to have it 2 spaces up and full of liquid uranium. Hot. I think that would be the thing. 1, 2, and then we can walk through here. We would not be there with a liquid space for our input. Let's save more space. We would possibly extend this. I don't know. No, I don't think so. 1 pump is enough. So we're gonna have our regular guys here. Is the thing. Just a regular guys here. Not a terraformer. But sure, it is nice. And for heat control, a single chamber that will produce some enriched uranium metal from the terraformer. It's going to use the heat for power. There's going to sit a aqua tuner inside, and we're going to have a heat sink as well. Oof. It's going to chamber into here. Wait. The coolest thing needs to be... Oh, how cool. Hydrogen cool. So very cool. So that's gonna run somewhere. And the hot stuff is just going to loop around here. Looping around. And then going back if we need more cooling is a good plan. But the debris chiller might be somewhere else. Good question where to build this all. But that is what we're trying to do, right? Let's check our text document. How to make a brain gas? Yes. Hydrogen liquidization inside rocket. Yep, that is the only thing that is missing. And unfortunately, that is the most complicated thing. Or fortunately, so we have something to do. But yeah, the brine geyser goes somewhere else. But where? If you produce a hot over here, hot, cold. What if we connect? If we immediately connect, I think that's fine. Oh, we're gonna have a door here. And then the thing here, and then the steam chamber there. Dum, bum, bum, bum. And then over there, the steam turbine. But the steam turbine chamber must be very big. And I think I wanted to have the liquid oxygen chamber. A big chamber with a steam turbine in as well. And we might run hot stuff through. But that might be madness. Bum bum bum. But this is so cool. Oh, something is missing here, and that is a pump. Luckily there is enough room. We could even do a double pump. Take the measure. But yeah, I think this I definitely want. This is just too beautiful. Good. Going to bring the meat and the uranium. Nuclear waste, we're just gonna drop somewhere off. Or leave on the floor? I'm not sure. Dum bum bum bum. Maybe we're not even gonna have uranium, nuclear waste over here. Bees are getting digested by the plants. So maybe they don't leave anything behind. Except for plant meat, of course. Good. So now we're reproducing, and we're gonna be in here. We could do an Escher and all the jazz, but let's filter destroy all, and be careful what we're doing. Let's pause the game. This is nice, sure. It's extremely nice. Get rid of it. And see if we can build it again. Bum 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 bum. Bum 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 bum. Careful now. We don't want to destroy things we want to keep. Good. Looking clean. Dun, 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 dun. Are we going to build this from hot? Or are we going to build this from insulation? Bum bum bum. And how hot is it going to be? So we will produce the heat. There is a pump inside. Will it stay stable? Yeah, sure. If If we start out with a nominal heat, it's going to stay stable. What is the temperature we can do? Let's try a steel pump. Let's try a thermium pump. Let's try a niobium pump. Good. Let's try a gold amalgam pump. Good. So these are the differences in pumpage. So this is just 75 degrees a normal copper pump. 75 degrees and it will break over your temperature. So that's no good. Steel pump is 275. Thermium is 975. And gold amalgam is only 125. And niobium is 5. So my guess is we're going to use niobium at this stage of the game. Good. Makes a sense. Alright, will we have enough insulation to insulate ourselves in properly? Don't know. How much do we need? Insulated. Let's find out. Good, we're coming in here, and this pattern you should remember if you want to do a terraformer, because this is an entryway, and then this pit will hold a, what's it called, spring. Okay, we're gonna spring in here. But uranium, that's new. Let's check the wiki. We're going to check the wiki over here. And we're going to look for liquids. Bam, bam, ba, bam. Crude oil, supercoolant, nuclear waste, naphtha, petroleum resin, ethanol, brine, saltwater, polluted water, and viscous gel. That is a nice, colorful thingy. But what we're looking for is a liquid enriched uranium. Bum, 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 bum. Liquid uranium, there it is. Bum, bum, bum. Oh, it's going to solidify into depleted? Well, that makes sense. That's just fine. Good. Dun, dun. So what can we put on top? Anything, right? We sort it here by density. I hope. Ordered by density from lightest to heaviest, yes. Good, so anything we can put on top, that is really good. So what can resist the temperature of 500 degrees? Molten lead? Liquid gold? Does it tell me the viscosity in the wiki? I already know the answer. The wiki does not have all stats. Density 1, 4, 10, 12, 15, 16. Thermal range, evaporation temperature, freezing temperature. Yeah, it's nice, but viscosity would be more interesting. Evaporates, freezes into. Nope, it does not. Let's edit. I might edit this. But it's a bunch of work. Should we? Maybe I'm gonna have a dedicated stream to editing the wiki. What it needs here is viscosity, mass per tile, and 2 other stats. I completely forgot. I have to write this down one time, because there are 4 hidden stats that every liquid has. Good. What we're gonna put on top. Gold is a bit viscose, so I do not know. Liquid phosphorus vaporizes at 200 degrees. Liquid sulfur. That is an idea. Molten salt will freeze into salt. Way too early. Bum, bum, bum. Liquid sulfur is quite Not viscose. What is the opposite of viscose? Somebody tell me. Loose? I think it could be used. So all I have is my experience in the game to tell me if it's viscose or not. Sulfur 300 degrees. What can we do? 337 is the maximum. 33. Let's do 333. Good. So 333 is what we're going for temperature wise. Bum bum. Good. So how is this looking? We're dropping through here. Bum bum. Bum 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 bum. And this is the other spring. And here we have something else. Good. And we need to close this off. Good. Notice how we cannot reach here, but that's fine. This is all going to be closed off, and we can reach to the middle from here. That's a good idea, I'm sure. And here is going to be... we need now something resistant to 300 degrees, but that is no big deal. Let's experiment with the drywalls. Bum bum bum. What solid drywall do we have? This yellowish? We make it from sedimentary. How does this look? Oh yeah. Why not? Good. Will this melt? No. Good. Dum bum bam. Oops, my mistake. Then we're going to drop on top of a solid tile here, and then we're gonna flow here and there. But we're not just gonna flow here. I think we do 1 1 2 2, and then another one here, and then the door system. I love this build. Good. Is very nice. It's very satisfying to look at as well. I can only recommend the material color mod. Look how boring this looks. Bum bum bum. And then the material color mod. Whoosh. All of a sudden it's vibrant. Genius. Needs to be implemented into the main game. But Tencent is too busy cracking the whip. Right? Now, what do we need to do? More background tiles, of course. Doors, that's right, doors. We're gonna do nice and blue doors from Cobalt. And they're gonna be here. And then 1, 2, 3. And then 1, 2. And that leaves us room for an Escher. I'm gonna try a triple Escher here. Just for kicks. There is no reason to do this. You could have a solid tile here and then put a triple Escher. Kinda prestigious. Let's lock the door. Copy settings. Alright. This is gonna stay empty. We're going to flow on top. And the temperature is not important. So what we could do is have another door here. Or just any tiles. Let's just do any tiles. Let's do obsidian tiles. Is that smart? Remember, these doors will take on temperature. So we have to preheat. Bum 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 bum. I think I'm going to quickly preheat these doors. Just for kicks. Plumbing, liquid pump. Let's make this realistic. Niobium. If I preheat the doors, preheating the background tiles is also important. How do we achieve that? There is no achieving that. Properties, 100 key. There is no achieving this. 100 key, and here we got 200 key. I don't want to use the temp shift plates here everywhere. I could. Automation, shipping, utilities, temp shift plate, utilities, temp shift plates, sedimentary rock. Sand cement? No. Brick? No. Building slab? No. Sandstone. Solid ethanol. A temp shift plate from solid ethanol. But where is the sedimentary rock? Here's mafic rock. We're close. Mafic rock looks how? Disgusting. Sedimentary rock. It's gotta be here somewhere. I cannot search. Search bar implementation fail. Sedimentary rock. Here we are. Of course, I like the bright green better. But let's do filter destroy all. Good. I wonder if now the insulation will take on the temperature there. Do not know. But let's make it happen. Let's make it fappen. Good. Man, I like the green. Dum bum bum. Good, we will have the insulation to build these two towns. No big deal. And the overflow flows in there. How do we reach? Fidget says left shift X. Oh, good to know. Well, like so. If we overflow, that's gonna happen. A temporary tile. Over here. And then we're gonna pour the uranium. Dum, bum, 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 bum. Good. Plumbing. Liquid vent. Good. This is still 20 degree everything. I wonder if everything heats up if I run the loop here. Let's find out. Plumbing. 3 through 3 we could do, but we can use another liquid for priming. What is the temperature here? Overheat. 575. What is realistic to have? Liquid uranium again. Yeah, let's just use liquid uranium. The rest we have from melting the rocket. Where is that and how much do we have? Building electricity, that's the grill. Good. So 690 kilograms of liquid uranium, and the temperature is 2600 degrees. What's broken here? 2600 degrees. Let's check the interior. Get rid of the rest over here. Clear. Good. 2600 degrees. Brush in uranium. Enriched liquid. 2600 degrees. That will break things, will it not? Especially the background tiles here. Sedimentary rock, yep. Deconstruct. Here the insulation is good. 2600 degrees. Good question. 2600 degrees. Obsidian then. That's very black. 2,700. There we go. There we go. Good liquid uranium. And we had about 600, I don't know, 650 kilograms. Let's put it there. Damage overheat. Of course, the liquid pump is overheating. Going to disable the auto repair. And we're going to pump it immediately to preheat the doors and everything, hopefully. Don't know if it works. Cement rock, obsidian. Obsidian is good. We are going to run like so. That is good enough. Going to run around. This needs power. Good. Conductive wire. And a cheat gen. Good. So now we're pumping the liquid uranium. Let's see what happens. These pipes will melt to 2.7, so no problem. And the doors are going to heat up a little bit. And the uranium will cool down a little bit as well. What happens to the temperature plates? Same. Same. Nothing. So over here we have a problem. Huh. That means we probably have to connect everything with the doors more. Kind of don't like that much. What if we just pour the hot uranium in directly? And see what gives. We go through here and there. All right. Are we going to freeze? We could hear. Oh, it's breaking the sedimentary, of course. Arc. Deconstruct. Background tells. Oh, that is sad. But that also means we don't need temperature plates. That is absolute overkill. 800 key, that's a lot we would have to heat up. No need. Good. Instead, going to put in regular background tiles from obsidian because we don't have another choice. How is a blue obsidian wall looking? I can barely see. How's the yellow one looking? Disgusting. How's the fresh white looking? Very grey. How's the pink one looking? Purplish. There's a bit of a purple clash here. Look. Blue is a dark blue. Is a little bit of a blue clash with the doors. I think the best would be charcoal black. Extremely stylish. Good. Bam. Wait, do we need this? No. This is the liquid that we need. Let's clear the thing. Good. We're not spilling over, and that might become a problem. How much do we need then? Well, I'm sure we're gonna find out. Let's pump it out. Aha, we have spillage. Hold on. Dude. Normal speed. Bam, boom, boom. So we do have spillage. When are we going to do what? Oh, wait a minute. This is not enough liquid. And it immediately won against everything here, but it will not win against the door. Good, let's brush in more liquid uranium. Way more. Oh, that might have been too much. What is this? Niobium, rare resource. Is alright. So we will not heat that up anyhow, so it's good that we took out some of the heat. Plumbing, liquid pump, go. Oh, it's more melted. Good, damage overheating. What about these pipes? Let's get rid of them. And pour in more. So at which point are we going to put in the Escher? 10 kilograms, doesn't look like much. Oh. Did we forget anything here? No. Oh, we just need a lot of liquid here. Oops, we are melting insulation? Is that really the case? How? No, we melted the cobalt. Now we have liquid cobalt. Let's mop it up. Ah, but I wanted to have cobalt here. 1400. Rotate. I'm gonna be stubborn here. I want cobalt. 1400 is more than enough. Copy settings. 1700. What is the temperature here? Way too hot. Let's brush in. 1000 degrees, also too hot. Let's do 500 degrees. Here, 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 here. Whoosh. This is not nearly enough, or what is going on? How much is there in one spot? I do not know. But once we have this here, we can put in the Escher. Good. On top goes hydrogen. Let's take some. This is too much. Sample out. No, we're gonna brush it in directly. Good. Hydrogen. Gas. Just a speck. Temperature. Doesn't matter. Good. What else is a good gas? Carbon dioxide, of course, but what goes in between? And I cannot see the dog. There he is. Good. What goes in between hydrogen and carbon dioxide? Chlorine, natural gas. Will we have natural gas? Possibly. Let's do let's do natural gas. Why not? Natural is gonna be a little bit. And then we're gonna put in carbon dioxide. Good. And we have a triple Escher. Good, let's hope this does not melt again. It's heating up quite a lot. And we melted. Settings. Sample. Brush. Good. Don't melt. This will melt as well. 900. Why is this not transferring heat here? Nicely. That is what I want to know. Good. 400, 700, 600, 2000 degrees here. There is a bit of an issue. Liquid uranium 700 degrees. So that is better. Where's the hot one coming from? Nowhere. It's still hot here. It should cool down, but it does not. And we melt it again. Oh, this is so annoying. Tell you what, we're going to start over. Good, we're gonna bring in 500 degrees hot stuff. Dim dim dim. Brush in. Bum bum. Escher is still good. Brush me in. Oh. You have to spill over something here. 300 degrees. So crude oil would work. What is heavier than it is only crude oil. If we check back on our little table there, on the liquids, we find out that the liquid uranium... Oh, crude oil we cannot use. Cobalt. But it will not stay liquid at the low temperatures. Oops, dee-doo, so everything here is pointless. Damn it. Now that's not good. That is bad. But isn't there a spillover trick using mesh tiles or something? How does this work? I don't know if this is functional. Dun, dun, dun. Isn't this like so? No. Also the space exposure, I don't know if it's real or not. Bum 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 bum. So we're not getting anything here. This looks like it's emptying out into space. That's not good. Bum 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 bum. Deconstruct background tiles. So how is this looking if you use a mesh tile? When you use a mesh tile, it's right below the spring every time. Oh, this is non-functional. No, here it is at the spring. So which one is it? At the spring or below the spring? I have no idea. Dun, bum, 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 bum. And now you're wondering, but the space exposure. And you're right. Space exposure is a problem. We're going to use a pixel pack in order to trick the game in having a background tile. Thermium is good. Alright, no more space exposure. It says vacuum here. But we're not supposed to believe that, are we? Let's brush in liquid uranium. 6,000 kilograms. Good, we're going out. And we're filling up here. Right, but this is how we're gonna do it. We're gonna pump this stuff in. How much is there? Oh, getting this will be a bit rough. We need all the uranium in the map for this project. But let's pretend we will get it. Good. We're gonna have a filter destroy all. And then we're gonna brush in more of the stuff. 700 degrees? In the end, no. In the end, we're gonna be 333 degrees. But we're already too hot, aren't we? I think we are. When is this going to freeze? I don't know. We do have over spillage, which is good. Don't give me that alert. And we're spilling. What we don't need is, oops, this and that. And it's spilling through as well. But we could install the spring to see if it works. Except the temperature's wrong. Oh, sorry. Temperature is wrong. Let's sample this. 333. Brush. Enter. Good. Now the temperature is the same. Eh? 333. Mass 100 kilograms? It does not override is the problem. Good. But the mass is 10 tons. 10 tons. 10 tons of the stuff? Which is a bit much. 10 tons is a lot. Brush in 10,000 kilograms. 300 degrees. 300 is good enough. Because we have other mothers. Alright. Then we're going to exchange temperature here. And that is because our spring is going to be from... What was that? Dun, 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 dun. Oh, sulfur, that's right. Sulfur liquid 337 is going to be gas. So we got to be careful. 337 is going to be gas, so this is too much again. Let's do 200 degrees. Brush. 200. Good. Alright. Sulfur will work. But what is the spring size? Let's brush in sulfur. Liquid. At 200 degrees. And we're gonna say point. Let's say it's water. It's not gonna be like water, is it? It immediately gasified. Oh, that sucker. Did not mean for that to happen. It's too hot, why? Where are we? 700 degrees. The mesh tower. The mesh tower. What else? 700 degrees? Nothing. Boom, 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 boom. Huh, this is funny. For to destroy. Elements? No. Gases. Doesn't work like that, does it? Let's just sample some vacuum and fill. And then we're gonna brush in again. The liquid sulfur at 1 sensor. 0.06. If it has the same viscosity as water, that will work. And it immediately flashed again. Why? The charcoal is still hot. That's not good. Sample, fill. What else is hot? The charcoal is hot, the pixel pack is hot. But the rest is not hot. Good. Uranium, 230 degrees. That would work. Let's brush it in. I want everything to be 230 degrees, and it is. Good. Now this is of course too much. Let's mop it up. Alright, we have a waterfall. That is good. Now we have to find a way to break the waterfall. As well. Let's see if we can find a way to break the waterfall. Let's sample a hydrogen, brush it in. Good. What if there was a tile here? Kind of breaks the waterfall, but not really. I need a spillage there. But it will not spill over. If I had some liquid cobalt over here, I cannot have two different temperatures here and there. Or could I? That is probably what I would need to do. But first things first. Sulfur. Going to brush in. Is the game too loud? Certainly is a little bit loud for me. Let's take down that sound. And listen to the music some more. Because there's a lot of spilling now. Good. Going to brush in some sulfur. Again. This time it should hold. 0.06. If it has the same viscosity as water, and it does not. 0.4 if it has the same viscosity as petroleum. And it does. Good. Now all we need to do is get this waterfall to do its thing. If I put in a mesh tile here, high thermal conductivity from, say, pirate. Not allowed to do this, damn it. Deconstruct. Mesh tile. Good. Melting at 1000. Good, good, good. Pixel pack. In the end, we have to heat up the mesh tile, probably. But a pixel pack? Maybe. Don't know. Furniture? Good. What is your temperature then going to be? High thermal conductivity. Slow heating depleted uranium. Let's do it. And suppress. And don't freeze the sulfur. Good, so that does not work. Maybe it will work here. don't know. We have to deconstruct and deconstruct. And clear. Do the thingy. And put in the pixel pack. And don't annoy me with the alert. Still no good. What if we go on top of it? Deconstruct. And this clearly does not work. But we need to split the waterfall anyhow, or maybe not. Deconstruct background tiles. Here is going to be a mesh. Good. And let's see. Nope. No. So this is how it works. We're coming out here. And immediately there is a mesh tile. And then this is the same height as the spring. Here on the other hand, we're below the spring. Coming out there. And without the mesh tile, this would not work. What is the difference? I don't even know. This is functional over here. Let's experiment for a second. This is still functional. No, it's not functional. But what if we did not have a useless atmosphere? But we will have a useless. It was working there for a second. Good. That means this doesn't work, of course. Let's deconstruct the building. Get the old system going again. Aha. Good. Old system is going again. But this would also work in a vacuum. In a not vacuum, that will not work. So, if we were to come out directly here, but how does it come out directly there? Let's signify this. So that would also work. Top thing works. Why? Don't know the mechanic behind it. But both would work. Wait a minute. Both works. But for the little space, there must be a vacuum for it to work. Alright. Good. So where are we coming through? Ah, sulfur and liquid uranium almost same color. That's hawk. That's a dog. Good. These mesh shards don't seem to do anything. If we were to come out here, which is not possible. If we were to come out there. Or just to spill in this space. That is the same as... But it does not matter, we need to split this into a bead anyhow. So just for testing purposes. If we have cobalt here, brush in cobalt. That will work for a minute or so. Size and mass. Cobalt is very viscose, so we can do 7 kilos without overspilling. I think these are magic numbers. 300 grams, 7 kilos. Because 400 grams will overspill and 8 kilos will overspill in the viscosity thingies. Probably. Good, it doesn't matter. What is the temperature again? Let's find out. Auction include wiki, yeah, I know. Liquid uranium. This will freeze at 1400, so if I do 1500, it will hold a while and it will transfer heat, which I don't like. Dog really wants something now. Well, it is lunchtime for the dog. Let's brush in 7 key of 1500 degrees molten cobalt. And it immediately freezes. There wasn't even one bead split. Damn it. I have to split this a different way. Let's try to pour over here into a mesh towel there. But I'm hoping here against hope. Da da dum dum. Dum ba ba bum bum bum. Yep. This is nice and all, but it doesn't work. Actually, it's not even that nice. This is so mean that we don't have a liquid there that does it for us. Good, but if we look at this table, we find that there is only liquid cobalt. So we must run this very hot. Simple. We must run this at 1500 degrees minimum. 1500 degrees minimum. We can build this, but not with cobalt or doors. Deconstruct buildings. 1500 degrees. So what material would be good? Let's pretend niobium is good enough. Rotate. Pump, 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 pump. Switches up the style of the thing immediately. Properties. Melting point, yes. Good enough. Lock the door. Copy settings. Good. And then we're going to mop up this. 1500. Will the obsidian hold? I think it would. Pixel packs no longer needed. Mesh tiles no longer needed. Here we're gonna go, and there we're gonna go. Gonna mop up this jazz. Gonna go straight here. Do it like that. Oh, that's not needed. Good. Clean up the space. Liquid sulfur is then not going to work. Good. Let's check again. The liquids. What can be on top of liquid uranium that holds a 1500 degrees? Gold? What does this mean? 1000. It freezes at 1000. Liquid tungsten freezes it. 3400 degrees. Niobium, petroleum. Liquid steel would work. Liquid copper. Liquid iron. Then we would have to go up to 1600 degrees. Magma? Magma. But it's very viscose. But everything there is probably going to be very viscose. Liquid carbon. Liquid carbon. Wow. Magma is readily available. But iron? Steel. We should have some leftover steel. How do I test the viscosity of materials? Don't know, but let's do it. Before we feed the dog. He's like, yeah, give me food. This can spill? Yes, it can. But let's put in the 1500 degrees. Molten cobalt, 1500 degrees, 7 key. Sure. Brush that in. Here where it belongs. Brush that in here where it belongs. Damn it. Solid charcoal still not enough. Almost. That is just too dumb. Let's take out this. Liquid uranium. We're gonna say 10,000. And we're gonna say 1500. Sure. Good, and then we're gonna put it here. Oh, we're still on a sampling. Full and brush. Good. 1, 2, 3, 4, 5. Are we going to spill over here? Possibly yes. Let's go. Cobalt is heating up. It's too much though. Dog. A little bit more patience, dude. Just a tiny tad more patience. We're not at 1500. Looks like we're gonna go there. Good. 1500. Brush in cobalt. Oh, there it is. Liquid. Or molten. Adjust mass. 7 is good. Sure, 2000 degrees. And we're immediately freezing. Try again. Try again. It's going on top. Oh. Oh, and that was my mistake. It's not supposed to go on top. But why would it go on top? That's wrong. What is the question mark here? Oh! The wiki! Oh, yeah, yeah. Liquid uranium is denser than... Wait. The density here is not sorted correctly. Man. Anybody can just write anything into the wiki. This is preposterous. How dare these plebs... I'm still in the Warhammer 40k mode. Where I'm playing a noble rogue trader. But, this is bad. Good. A supercoolant. 400 degrees. It's going to evaporate at 400 degrees. So supercoolant we could use. And the liquid uranium could be at a nominal of 300 degrees. Good. If we can trust these numbers. Man. I wasn't reading the numbers, I was just trusting the visual there. Good, let's mop up the too hot stuff. Let's mop up the floor. And we're going to fill in supercoolant. Ugh, and now everything is in the wrong temperature again, 1400 degrees. But let's just brush in a little bit of liquid uranium then. Uranium liquid at the temperature that we want, right? 300 degrees. Pop, 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 pop. This might be too much, but I want everything sorted. 423, and the wiki says a supercoolant 436 in terms of vaporization. Good. So that would work, and we would overspill as soon as this is done. Hold on. It's too much. Too much liquid. Spill it out a little bit. Good. A supercoolant here. Brush in super duper coolant. Solid? No. Liquid. Temperature 333. Mass 0.1. No. 0.1 will spill over. 0.03. There we go. We have a waterfall. Brilliant. Brilliant. This is a success. Wonderful. Let's sample some hydrogen gas and split the waterfall. Boom. Oh man, this is beautiful. Now we just have to put something on top. Also, this is wrong. Get rid of this. Let's put something on top, and that is going to be sulfur, right? Right. What is the temperature of the charcoal? 350. Brush in sulfur. Gonna be... what was the spillage again? Same as oil, right? Right. And if only somebody would go into the wiki. Well, if it's same as oil, 0.4 or 0.5 doesn't matter. Good, liquid sulfur. Gonna put it in both directions simultaneously. But the temperature is gonna be 333. Here and there. And we have production. Let it spill over. And out. Good. 800 in. Look at the liquid. Producing here. 86. We're getting pushed. We are getting pushed. This is gonna take a while. How big is the bead? How big is the bead? Bum 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 bum. 100 key as well. Oh, beautiful. That is quite nice. Hey! You're not supposed to produce that many bees. It doesn't know what it's doing. Critter sensor. It's because it's inside of a rocket. It's not supposed to know that it doesn't have. It's standing in nothing. It's glitchy. Ah, and we're producing. Good. Alright, that's very successful. Time to feed the dog. I will be right back. But first I'm gonna save the game, of course. Gonna adjust the camera. It's gonna be a very enjoyable feed, maybe. Alright, back to it. Dog is having their food, that's good. What we need to do now is collect the stuff, install a pump, and then run the uranium through somewhere. But first we're gonna collect it. Good. Manual airlock, deconstruct. We're going to collect it. And this is all reachable. All we need is a ladder here. Or there even. And then duplicates can just... Up on top we can do a ladder. From obsidian. Good. And then the duplicates can reach everything. Well, not down here yet. Good. But this will be reachable. And inside... So we're coming in... Deconstruct buildings. Dum bum bum. Box it in. Like so. Good. Temperature is accumulating. Cup settings. Chuk chuk chuk. Solid charcoal background. Alright. And this will take a good while until it's filled up. And then we're gonna have a pump from niobium. And that is going to run the hot stuff somewhere. Let's deconstruct this. Is no longer needed. Granted, here we're probably gonna have suits to build this. And it might be a good idea to build this first. Maybe. How do we preheat things? Because I do want to produce as soon as possible. Don't know. 333 degrees. Don't know. Obsidian. Then these insulated tiles could be obsidian tiles as well. Building this from obsidian and niobium is absolutely feasible. Good. But we're producing relatively fast. If this is 10,000 kilograms, we can build in an Escher. Building an Escher here could be somewhat complicated. But if we bring a gas... If we bring a gas here and release it, it will not escape, will it? I think it might. If we bring it here and then it goes up and then checks if it can go upwards even more. But if we release it in this spot, it checks and it says there is a roof. And that could work. Can we test this? We need a bottle of gas. Dum 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 dum. Oh, and that means we have to build the door later. Build the door later. Could be. Oh no! Ah, this is impossible. That is is impossible because the duplicate needs a little bit of room in order to open a gas thingy. So if we run then a pipe, maybe we could. Good. So let's say this is 10,000. It almost is 10,000. Let's cheat it in. Like so. Bam, 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 bam. Good. Now we're overproducing. There's a vacuum. But that will soon not be the case anymore. Good. Then we need a ventilation system. Dog, what are you doing? Where's the dog? Oh, he tossed the camera into his bowl. What are you doing there? Tango. Tango. Pop. No, Django, that's it. You're on a diet, boy. You're on a diet. Go. Up, up, up. Up, up. That guy. Up. No. Tango. Good boy. Good boy. He needs to know that there's no more food. Poor guy. But we don't want him to become like the fat cat. That would be bad for the dog. Poor dog. He can't. He cannot know what is good for him. Unlike the fat cat, he knows that food is good. Now we're gonna pump this. From here, any pump is good. Gonna get a def cheat gen. Connect. Ventilation. Gas pipe obsidian. And see what happens. Oh, we're overpressured. That's not good. How much is there? 500 key. And when is an overpressure gas pump overpressured? 20 key. So we have to do this a bit earlier. Dum, da, da, dum, 300, 200. $60. Damn it. We're just producing too much. And we cannot stop the production. How do we figure this out? What if we were to do something like this? And I had a temporary tile over here. And I had a temporary tile. I cannot have a temporary tile. But we could build that door last. See what gives. Boop boop. Yeah, that's good. And that seems to be alright. And then we're gonna stop the madness. And oh no, that was too much. Damn it. Oh. Oof. Let's So a temporary tile here again. Then we have the hydrogen there. And then... Cannot build a door here, or could we with a duplicate? Good question. Let's say it's possible to build a door here. And then we overbuild here. Or we wait until we have enough pressure. Good, let's not wait. Let's brush in. Alright. But we're not coming in, are we? We're stuck. Yep, that's what I thought. There is no way. There is no way. Da, 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 da. We probably have to do a little bit more. Da, 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 da. Let's do more. Deconstruct. Bum 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 ba da ba dum. Ba da ba da ba da ba bum. Deconstruct. Deconstruct. Put it in. Bum ba bum. And up there. Gonna say no. Good. Copy settings. Dun, dun, dun. And where's my pump? Deconstructed it. Oh yeah. Ba-da-bum. Here it goes. Alright, can't be helped. If you want an Escher, this is what we have to do. But what's going on down here? Gonna do a triple Escher again. It might be possible. Good, let's see what happens. Cut the pipe for a moment. Oh, disable building, huh. Good call. Alright, this should squish in the hydrogen into one spot here when we're full. Let's sample and brush in. Dum 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 dum. But we're not coming in. That's fine-ish. Delete this with a duplicate. Overbuild. That is good. Now we're going to bring some carbon dioxide here in a bottle and empty it out there. Brush. Carbon dioxide. Or natural gas. Natural gas. Carbonation. Natural gas. One key, whatever. And it got pushed over. Dun, dun, dun. In the end, I have to move all of this over one tile. Dun, dun, dun. Clean up. Unless I do another triple Escher. Carbon dioxide. Good. Like so. Ha! Ha! Sweet. And that is a triangle triple Escher. And you can see this first in Havoc's post on the waterfall something or another. I can't remember. But they used very little amounts of triple Escher gas to block heat, and then they were using a contactless pump, I think, and a waterfall to trick the contactless pump into pumping, which is genius. And I will not build this. It is too genius for me. That is Havoc's prerogative, not mine. Good. Now we're gonna put in our plumbing here. And it's gonna be a niobium. Good. Wonderful. And then we can make use of this liquid uranium at 333 degrees, which will accumulate. And that will provide heat. And a little bit of extra energy. We're just gonna have a chamber that is always at about between 180 and 200 degrees Celsius. And genius. I love it very much. So does the dog. He's looking stupid. But yeah. Good. Now we're going to put everything. Where do we want to put everything? And this does not need to be insulation. What if this was obsidian right off the bat? Bum bum. Boom boom. Very dark. And it's increasing in heat. It's taking heat out of the liquids. The supercoolant is... Oh, the sulfur broke. The sulfur broke. No big deal. It's also heating up again. How much is this? 400G. Yeah. It will figure itself out. The heat is quite stable over here. Let's check the bead again. Bead size is 100 kilogram. Yeah, this is a lot. Here's the question. If I empty the bottle there of the hydrogen, will it stop up there or will it escape? We're going to test this in survival. Deconstruct. Deconstruct. Mop up the floor. Oh no, I mopped up the sulfur. No, I did not. It liquefied. Good. Nice. What is this here? Liquid naphtha. Oh yeah, because I deconstructed that thing. And that must have deleted important gas. Another reason to use a bottle. Hey, should we test this out? Let's test this out. Let's sample vacuum. And let this pour out. Good, and then we're going to brush in hydrogen, gas. One key is fine. Doesn't matter. So a duplicant is going to open a 1 kilogram bottle of hydrogen down here. That works. That works. A duplicant is going to open a 1 key bottle of natural gas. Down here. Oh, this is already working. Oh, because we're so high pressure. Is this realistic? Probably not. But we can do a triple Escher if we're not realistic. Let's do this. Carbon dioxide emptying out here. Oh, now we have a triple Escher vertical. That's not realistic. That is just too unrealistic. Let's brush in the carbon dioxide gas here. That is realistic then. Good. That's looking fine. How's the radiation? How is the radiation? Well, liquid uranium gives off radiation. Maximum hazard even. So if we need this for plants, is a good call. Bam, bam. We can plant Weezwort down here. That is a bit insane because we're touching 300 degrees here. That will not work. But realistically, this space is wasted. Bum, 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 bum. Good. But it's just beautiful. Can barely see the sulfur difference. But that works nice. Good. So we have a heat source inside of the rocket. 300 degrees. 333. Alright. Now, what I want to do is have a single steam chamber. And then we're going to cool down the supercoolant down to hydrogen liquefying temperatures. And we're going to split off the loop before we reach those temperatures. And keep it stable somewhere. So we're going to bridge on the very cool loop into the not so cool loop. And if the not so cool loop is too full or too warm, is going to eject out the liquid into the very cool chamber. That's hard to explain. But we're going to have at least 3 different temperatures. No, we're going to have 3 different temperatures. Exactly. We need one chamber that is extremely cold. And I don't know if it's going to be here or not. Entryway into the base. 1, 2, 3. 1, 2, 1, 2. Entryway into the base. I want to be a nature reserve. But this is probably all not how it's gonna look. Steam turbine here, no. This is safe temperature. We're gonna close this off in the end. No, I don't want any of this. Deconstruct buildings. I don't want any of this. The cooling loop we're gonna leave in though. Good. Deconstruct all these buildings. Don't have any power, of course. Temperature is at -17. It's not much. So all we need is love and a little bit of this here. Deconstruct. A little bit of this room. Hold on. We're probably gonna need to pump this out into a chamber. If we had a very cool chamber below, we would need to insulate ourselves in. 3 probably need complete insulation. Yeah. So if that liquid reservoir is gone, then how do we push everything? Let's push the hydrogen back in. Good. Alright. And deconstruct. And that will spill there. Or not. Because we have a vacuum. Good. Can we make this normal? We can. Good. Now we're gonna pump the hydrogen into a chamber where it's going to liquefy. But the liquefaction chamber is also going to be the debris chiller. This is going to chill the debris very quickly. So we're going to have liquid hydrogen in the chamber and debris run through it. Right. That is going to be minus 250 degrees or so, I don't know. Hydrogen, properties, minus 250, yeah. So it says minus 252.2, which is then 250, round up 3 plus 3, 6, 256 minus degrees. Could be a good temperature for liquefaction chamber. Hydrogen. Yes. A hydrogen liquefaction chamber. That's what I meant to say. Good. Hydrogen liquefaction chamber is gonna be downstairs here, maybe. So that is the coldest temperature. What are we gonna have inside? A steam turbine, so we were almost correct here in the setup. We can build more and more. We can have this not be part of anything. This is steel and it's going to transfer heat very well. Let's suppress the alerts, we don't need them. How much do we have equipment? Oh, already so much. That is definitely a heat source. It's only 330 degrees, but why did we have this number for cobalt? Supercoolant? 430. But 300 degrees is good because we will not inadvertently vaporize liquid logs. This temperature is a good temperature. Good. How do we start this up again? Oh, we're just gonna pour uranium. Did I not have a gold guys here? I deconstructed. That was relatively flat for not using up so much space. What's the point there? Cannot pump then. Why did I have this? I can't remember. Yeah, this is molten niobium here. Obsidian insulated tiles, they are going to break. Is this a vacuum? No, this is oxygen. Let's open this up. Sour gas. disgusting. Let's use insulation here. Oops, I should have done that beforehand. Right, whatever. Good. So here's going to be the hydrogen liquefaction chamber, and below it is going to be the steam chamber. I think I have to build this. Bum 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 bum. What am I doing? I want to mop this. Good. How big is the chamber going to be? Look at hydrification. Oof. What is going to be in there? Not 100% sure. We're going to keep insulating ourselves in here. This entryway there. Why is it looking like that? We could have the door and the liquid lock in the same place. That is impossible to do, is it? Unless we pour it from above. Yeah, inside a rocket that is really hard to do. You would have to build the door first. And then on top of the mesh tile, it's not unfeasible over here. Since it is not, I'm going to pretend that I'm gonna do it in the end. Bum bum bum. Good, deconstruct. Mop. Bum 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 bum. Alright. How will we enter the chamber? And how is it going to look? Sorry. Definitely no supercoolant. Definitely no supercoolant. But supercoolant inside of a reservoir was not the worst idea. Good. Let's do that first. Do we have enough room here? What do we want? Debris chilling. A liquid hydrogen. And a steam turbine as well. I don't think that's a good idea, is it? Well, it does not look like I have enough room for everything anyhow. We need a pump. We need a reservoir. Liquid reservoir. We need a steam turbine. Oh, this could work. Need a steam turbine. And debris pushage. Shipping, I mean. Dum 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 dum. And this is going to be the last of it. That means, oh, could make this part of a heatsink. And I had an idea for another heatsink design. Let's quickly put it down before I forget. Bum bum bum. Good. clean me up, man. And then we need metal tiles. Whoop. And then we need in the vacuum the liquid valve. Any material is good. It is going to run through insulated and radiant. And insulated again. Good. And now the clue. If the temperature is correct, ship me out. Now, the question is, will the thing overheat? The conveyor shut off. Because it's a powered system. I don't know, but we're gonna find out definitely. Automation, solid, conveyor rail, thermosensor. Good, and now comes the clue. A background tile. Background tile here. And that way we can take the temperature. Good, we just have to pour in a lot of liquid. What is the best? In this case, petroleum. 700 kilogram of petroleum at 95 degrees Celsius. Let's brush it in. Good. And that is a new heatsink design. Brilliant, if I may say so myself. And the debris will run through from the heat chamber. It's coming from the heat chamber, so down there. Here, and it's going in, and then it takes the temperature inside the oil. Petroleum in this case. And then we're going out. Let's give this some power to see if it works. Or if it overheats just like that, or... Disabled by automation grid. Let's enable it. This will probably overheat. So, no problem. Going to have another 700 here. Sample. And brush. Genius. Good. Dum-dum-dum-dum-dum. And then the liquid valve is still in vacuum. Yep. Good. Conveyor loader. Power. Bum 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 bum. All. Good. Now, this is a heatsink model, and here it needs to be a steam chamber. So that's what we need in terms of space. Behind that. So we're gonna have another thing here. Same as we have down there. But our room to the right side is limited. What if we run through here? Do the liquid oxygen chamber on top and exchange heat when we want to. A heat exchange system between two chambers. Well, on top the hydrogen is gonna be warm anyhow. I think that's a good idea, so move everything down. Move everything down. What do we need? 2 tiles only, I think. I don't know. 2 tiles only. And the best way to exchange heat between two chambers is a vacuum door. But that would mean a lot of space wastage. On the other hand, squishing it in here could be possible. So that would mean the roof is over there. Deconstruct. The poor cooling loop. Deconstruct. Right, so that means 2 tiles here. Roof. There is going to be metal. No. There's going to be doors. Mm-hmm. And the stuff pours down even more. Good. So the layer of liquid is doors. Then we have metal tiles below and metal tiles above. And the metal tiles are the roof of the supercoolant chamber. Cannot doors, a roof. Supercoolant chamber roof. 3 tiles. How do we enter if this is on the right side? We don't. Let's make it on the left side then. That is more reasonable anyhow. Good, but this is the roof, so the left side is there. Good, 1, 2, 3. Which means we have a floor here. Good, 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 good. And this is extremely cold. So let's do something like that. Let's do background tiles everywhere. So we can do more painting. Wall ourselves in, of course. Good. How we do this? Let's box ourselves in. Since this is the floor, that steam chamber is below. Steam chamber holds a lot of stuff. Good. We have the floor here. Like I said, then 3, and then here is another mother. Oh, this is very good, I think. Don't know. Floor and floor. Possibly. Good. Cold chamber, hot chamber. Let's make it hot. Boom, 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 boom. Push the steam. Wait a minute. This is water now. Did we push it too much? And we want 4 actually. Tiles or 3. If this is 3, then that is the floor. This is the steam chamber. Is that true? I don't think it is. I think this is it. Good, but is that enough room? We just need a little bit of debris pushage to the left side into the heatsink. Good. Let's pour the coolant out. Here, possibly. Good. That means steam turbine goes here on the right somewhere. Oh no, we need this to be the roof. Otherwise the vehicles can walk over here. Right, will that work in the end? Good question. But first things first. This is insulated for a reason. We're gonna have our oxygen chamber here up top. To construct all this jazz. Oxygen chamber. Wait a minute. The floor of the oxygen chamber is of course metal. Metal tile. Niobium is good. Alright. And then we're gonna have doors. This is a vacuum, which is perfect. Good. Where are the doors? Mechanized airlock. Rotate. Good. And then we're gonna have a metal roof. Let's suppress all the alerts. Good. And then we're gonna have a hydrogen chamber here. With a heat sink there. On the left side. No problemo. 1, 2, 3. This is almost built in already. What a coincidence. Let's use some helper tiles so I can see what I'm even doing. This is my heatsink. There are many heatsinks, but this one is mine. And we're going to close it off. Building this in the right sequence is going to be a little bit of a challenge. Deconstruct buildings. But I think it's not unfeasible. It's not unfeasible to be loved by anyone. Put this here. Oops! We have a cooling loop here in the way. That must run somewhere else. Let's put the things in already. For the future. Pop up. Good. Automation though. Can go. Right, this door is locked. Doesn't matter. Heatsink. And then everything here to the right. But I'm not sure if we can. Alright, so the steam turbine goes here, of course. Rotate, and now we're overporting. I need to run this into a reservoir. But this is good. What about this supercoolant? Why is it not spilling? Yeah, it's spilled. Good, so we know where the steam turbine is going to be. Let's pump out the liquid into a reservoir. We're going to have a roof over here. Now in my mind, in my brain, that chamber is also going to be a nature reserve. Probably not feasible. What if I melt this as well? What do we need again? bunch of room. Steam turbine. Reservoir. Shipping. Did I miss anything? The power goes into a transformer, into the spine. Is there room for a transformer here? Probably. But that I kind of like. Let's just close this off forever and run the liquid into a reservoir, but where? In order to have an H reserve, probably need to get this moved somewhere. So I can deconstruct those. And room for liquid reservoir is then over here. Oh yeah, a pump we need. Oops, that is then no room. Pump for the liquid hydrogen. So it does not work. Can the liquid be here? In that spot? If I move everything over, I have exactly enough room for a pump and a steam turbine. That would help me out. Let's test. I'm going to deconstruct these buildings. Instead, we're going to put in background tiles here. Deconstruct. Move that over. Deconstruct. Building in the darkness there is dangerous. But we're gonna try. See if it works. Boop, boop, boop. Good. We need some liquid there. Save the game. If you mess with the liquid and mop it up in darkness, sometimes it crashes. I had that in survival. Let's brush in. Good. This is then our heat sink. Seems reasonable. Good. The pump is in the wrong space. Pump would be here. Just squishing it in. Good. Now we're gonna grab all the stuff. Put it in liquid reservoir. Let's say the liquid reservoir is here. We have to close ourselves in there then. That would move this over again. I don't think it's a big deal. Oh, the plastic. Good. Go with this. Intermittently, let's mop up the floor. Good. Alright. Solid nuclear waste. Delete it. Liquid reservoir. We have the nice steampunk liquid reservoir. Let's put it in. It's over there. Good. Any material. The pump is going to pump. And the loop is going to empty out. Wonderful. We need power. Let's connect it real quick. Alright. How's the loop looping? Liquid bridge we don't need. Deconstruct. Just empty out into the thing. Quickly. Where's my bottle? My bottle is gone. I mopped it up. Fecker says, auction not included. You have to earn it. And that's exactly what we're trying to do here. we're trying to make an oxygen chamber here below the Saturn critter trap farm, and this oxygen is going to liquefy. All we have to do is get a nominal hydrogen chamber below, and we need a lot of things for this hydrogen chamber. This is not enough supercoolant. Let's brush it in. Super duper coolant. Good to see you, Fat Cat. What's going on? Did you find a new show for me to watch? Maybe. I gave you the pig, the snake, and the pigeon. What can you give me? Just the normal. Just the normal. Well, to be fair, you already gave me Severance and Silo. I would have never found these shows on my own, ever. So I kind of owe you. You tried to give me Dark. Then that did not work out. Minus 35 degrees supercoolant. Let's mop it up. And pump it in. Really quickly. Oops, we're overspilling. Good, just pumping in the 5 tons. I don't know if this is going to be the space, but why not? Good, and then we could also do a power transformer here. Right, because we have the space. Good. Oh, we're empty. Beautiful. Deconstruct. All of that. Good. And here we're gonna build something similar. Good. You'll find something. Sounds good. So the debris chiller is having a heatsink here. Coming in from the other side. 95 degrees. Does not matter. This thing is sitting well in a vacuum. Then we got the shutoff from niobium and automation wire. Don't have a sample. We do have a sample. Good. Probably from niobium. We need to be powered. Is the shutoff gonna be self-powered? I don't think so. And this is now risky, building in the black. But we're gonna do it. Almost filled up here. Can we just fill it up? There's a button there. Add def pumps and pipes. Add def generator and electrical wires. No, this is already the best way to do it. Good, but power distribution is going to be an aqua tuner somewhere here. There's gonna be an aqua tuner somewhere here. But there is no room. What if we were to build it on top? Into here? Maybe possible. Well, this chamber does not need to be big at all. How many doors is good? I think 3 doors is just good enough. Good. Steam turbine. Chamber danger. Aqua tuner sits here. Aqua tuner sits there. Like a cell, maybe. Probably gonna close this off here. Who knows what I need there? Well, I know what I need there. And it's gonna be oxygen. Because the oxygen is not included. You have to You have to find it and process it. Are we 5 tons now? Yes, we are. Deconstruct. No, that pump must stay. But we're gonna mop the supercoolant, of course. Alright. Here is where we're going to pump in hay, and we have 1 space here. Genius. That is where we're going to pump in the hydrogen. From here. Good. How are we going to close this off? Just pretending that this is all that we need in this chamber. But did I not want to have debris here as well? It's going to be 95 degrees. Here, then it's going to run through this chamber. And in the end up in the liquid oxygen chamber. What a genius plan. This is a bit much. But why not? Good, let's run it already so we know what we're doing. Conveyor rail. Right, we're coming from down here, I'm sure. And then we go in there. And there. Through here. Through the oxygen chamber, but I think I might want to run through the liquid oxygen instead of the metal tiles. Good. Is there somewhere we need temp shift plates? I think 3 temp shift plates here are completely good enough. And with the oxygen maybe as well. Something like that. Good. And oxygen needs to get pumped out as well. So I'm not sure how big this chamber is going to be. But what we're going to do is take the temperature of the debris and then ship it out. Right, but first things first. We need a utility. There is a thermal aqua tuner. Oops. Good, I guess. And this pump is going to pump hydrogen. So, no more. Gonna build it later. Hey, we have room now. No more pumps in the way. Let's build the steam turbine right there. Rotate. From niobium, because we're gonna assume we have niobium. And we build this. And when we're done with everything, we're gonna finally know where to build the first machine inside of the rocket, which is going to be a brine geyser. But we have to build everything in, because I don't want to build the Hydra twice. And this here is good, but we're gonna do a filter destroy all and get rid of it, like so, because we have it over here. Plumbing, liquid vent, good. 2 hours 20. Oh my lord. Oh, we're gonna walk the dog in an hour or so. Then the steam turbine is going to get connected. A granite shore. Okay, so this is going to be 1 kilogram only. And power-wise, power distribution. Where is there room? Maybe even inside the steam chamber. What are we doing here? This is just... Why would I have the thermal aqua tuner inside of the liquid hydrogen thing? That makes no sense. It's nonsense. Here's the thermal aqua tuner gonna go. Maybe we move the power transformer as well. Good, but what I need here is grab the things. Oh, this again. 1, 2, 3, 1, 2, 3. Power distribution. Yes or no? Could be. And then get it out. Of course, steam chamber would be better 4 tiles up high, right? But I want to save myself some space here for farms and such. Good. But the liquid uranium is going to heat up the chamber. We're just going to pour it out here. Now, I'm not too sure if it's going to freeze too early. When is it going to freeze? Melting point. Wait. Liquid uranium freeze point. 132, so it's never going to freeze here. Wait, what? If it's never going to freeze, then it's just going to sit there. But if it freezes, it might freeze in the pipe here, if you're unlucky. So I have to run this in bursts. But that is a problem for until we actually have built everything. Because this steam chamber doesn't need heat input. Not even initially. Good. Shipping. Auto sweeper. This reaches everything. Good. Power distribution. Definitely need. Let's get rid of that there. Good. Power distribution here is a good idea. Thingy there, then we even have room for a power transformer. But we lack the room for a loader again. We do the reasonable thing. 4 tiles room. 4 tiles high room. Good. That is absolutely reasonable. Now we're gonna grab the stuff and run it through the chamber. Good, we're coming out somewhere, it doesn't matter. But running through the chamber where? From here? That goes there maybe? Because it does produce heat. We're going to connect it using an niobium wire. And then we're going into the spine, into power distribution over here. Spine is there. Good. The loader has space over here. But it needs dedicated power, so does this all. So we could bridge over and run through. Sure. Maybe. Utilities. Thermal aqua tuner goes here, rotate. And we're going to take the temperature of the liquid, as always, using a liquid pipe thermosensor. Put it there. Automate. Liquid loop. Liquid loop comes out. Bomb, bomb, bomb. It goes in here. So something simple for now. Right, this is going to be very cold. Oops. And we don't need to run through here. Can we run through there? We cannot. But I would love to. But I'm not allowed. Why do I need these 4 spaces there? I thought I would need them. For a pump, I do need them. Good. As unfortunate as it is, cooling loop can go only this far. Alright, plumbing. Liquid bridge, rotate. Coming in back in there. For overflow. This is the dumbest thing. Let's reverse. Thanks to Knost, we can do this. Just reverse the bridge direction. And then array liquid pipe from niobium. Good. Whoops. There we go. And then we go in again. Let's say, what was this? 250 something minus 257. Let's do that. If we're below, if we're above, to be honest, minus 200, then we're gonna cool down here everything. So we're cooling down, but we don't have power. That's fine. Auto sweeper and loader. Good loader. Right, we're loading the hot stuff. We're running it around a little bit. Good. Say all. Now power distribution. Power. We have room. Smart berry. Pom 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 pom. Power shut off. Whoop. Conductor fire bridge. Taking the stuff in from below. That means we can connect here. And we can connect there. Connect this all. Then we can bridge over here. Go straight like that. Let's not forget the conductor wire bridge over here. Oops. Oh, we're not allowed? Oh, but we're allowed here. And these bridges are from copper. Deconstruct. Deconstruct. Let's make them from niobium instead. Good. We're letting power out from the top right now. That means the right battery is letting power out when it has below. So a NOT gate then? NOT gate. Don't let power out when you don't have power. It's as easy as that. NOT. And we're gonna write the green signal over here. Is this the right material? Yep. Good. Connect. Go over there. This looks good. Bridge me over. Oh, wrong material. Hey, but I can click this wire bridge. Click on material, change it, and say niobium. But that didn't work. We have to order the rebuild as well. Oh, of course this doesn't work. Of course this doesn't work. Good. Niobium. Great new feature, by the way. And then we're gonna mop this up. Where's the dog? He's alright. Then we're gonna suppress there. No automation wire connected on the power shut off. What is going on? So that makes sense. Our first power is going to come from hydrogen generator from Hydra. Good, but let's pretend that we have that. Boost, we have power. Something's wrong. Taking in power even though we're full. Not letting out power, that is good. Bomb, bomb, bomb. Taking in power. Oh, we could take it in from taken in from below. That means the opposite. 5GK says bomb bomb. Good. Now we need to. I thought this was easy. Deconstruct. Deconstruct the Ribbon Rider and switch it around. And then we're gonna have power finally. But we need a NOT gate, of course. Where is it? Here. From Niobium, rotate. Boom. Good. Now we have power. Now we're cooling the liquid coolant here, the super coolant. And this chamber is going to become very cold. But currently we don't have an atmosphere, so nothing's going to happen. Except for the supercoolant is going to take on the very cold temperature. Because I say bomb bomb. Right. Conveyor shut off? No conveyor acceptable. What? Why? What am I doing here? This must run a different way. Good, we're running in here. Then we're going through and then we're going out. Genius. Whoopsie-woo, and there we go. That makes sense now? Good. Petroleum is still liquid. Now, the rear thermosensor says if we're below 100 degrees, I want the stuff shipped out. Good. And here we're going to have a similar thing. We're going to ship it into here. And the only room is over there. That's fine. That is alright. Good. Running through the whole chamber. Then we're taking the temperature over here. Don't think I like that too much. I'd rather take the temperature there. No, I'm not sure. And then we go out. I think we could leave this as is, like so. Conveyor thermosensor. Bomb and conveyor shut off. Beautiful. So that's then gonna work. Automation wire connect. Power, it already has power. Oh, very good. Very good. It always has power in between here. Seems reasonable. Good, if the temperature is below 200 degrees, then we're going to send this stuff out. We're going to say all. Let's see if it works. Good, where is it going to end up? Nowhere, genius. Let's build a chute. See what happens. Good. Any debris, any and all debris is going to get shipped out. Where would be the entrance of this chamber? Just going to have a liquid lock over here. And that means we have to be careful, because water will break things. We could have a liquid lock there. Yep. Let's do this, actually. Good. We're going to sample a little bit of liquid. Over here is fine. Brush it. Ah, yeah. That was too much. But no problem, we can mop it up simply. And here is then the entryway. Oh, that does not work, does it? Unless I melt these tiles. That's rough. Phew, we might have to do it though. So where is the debris going? Good. We are not below. We are below. 200 degrees Celsius. So we're coming out. Steam turbine is working as well. Nice. Cooling down everything. Wonderful. Now the niobium is getting shipped out. And in this cooling chamber is going to be very cold. So we should go into that chamber first. We should not cool it down that much. Should not mess with the hydrogen here. How can we prevent things? Conveyor thermosensors. Stop that there. Get everything out real quick. And connect this up directly. I don't know if this will work. Gonna save and reload the game and see if still everything is connected. Conveyors and powers. Thermosensor go. Clean up. Right speed again. Good. Pre-chilling and then chilling for real over here. Where the liquid oxygen is. Good, and then we're gonna get shipped out. But we should get shipped out outside of any build like that. But doesn't matter in this case. Good. Alright. We're producing a little bit of heat. Because the supercoolant is going to go down. This should be 95 degrees come time. Because it's the exhaust of the steam turbine. Alright. Well, this looks great. Here's gonna go a pump. That means we have to reroute the cooling loop. This pump is for liquid hydrogen. Let's reroute it like... maybe so. Good. And over here, what if we just run it straight? I think that's the better idea. Good. And deconstruct. Sticking out. Clean up the floor. And put in a liquid pump here. That is for hydrogen. Now we have to somehow make this chamber work. What do we need inside? Just a sensor for the doors, right? And the hydrogen can then drop down. And we need to be able to enter. There needs to be a vacuum lock. You could do a jump lock. Jump lock over here. Or just a regular vacuum lock. This is all part of the chamber. Ah, I don't want to move the liquid reservoir over. But that's what's going to happen in the end. Good. Let's empty out the cooling loop into the other reservoir. And something like that. Good. But still, I do need a vacuum lock entryway. And that would be here. Since we're 3 tiles high, jump lock is not unfeasible. And is not even that much a luxury. Good. So that is gone. Instead, we're gonna have a mesh tile here. Let's make it blue. Alright. It's a little bit more gas flow as well. But here, huh? What is this? This is in the way. Let's empty out the liquid real quick. Good. Then again I have our jump lock. And it is good that there's background here. We don't have to do too much then. And what is this there? Let's figure out the hydrogen. Could come in here. Easily. And then we're going to take the temperature. Are we going to take the temperature? Oh, we forgot something. And that is a thermosensor for the steam turbine. No big deal. Let's put one in. We're only going to delete heat if we are above 180 degrees Celsius. So what's the problem now? Turbine too hot. Oh, of course. Turbine too hot. Of course. We're gonna get hydrogen in here soon. That means we're heating up here a little bit. We should be able to deal with that. Could also stop the madness here. To stop producing heat. Good. It's emptying out. How are we looking over here then? This is some room we could use. There's a little bit of troubles. But in theory, if there was a blob of liquid here... Oh no. Well, a blob of liquid, I say. A blob of supercoolant. I mean, supercoolant is the best liquid lock. If it's a single blob. 0.0... What was this? 3 is good enough. Alright. And now this is going to be auction in here. And that is reachable if we have a ladder. And that is then the space we're working with. Good. Oxygen chamber. We need a pump for the liquid oxygen. And that's all gonna pump out here in the end. Liquid hydrogen, liquid oxygen. For refueling the rocket. And this here clearly does not work. Unless I melt. Unless I melt down this wall. What can we do instead? There is nothing much. There's nothing we can do. We can have a liquid lock entrance here. We could. Let's do something like that. Signify using a gold metal tile. This area is safe. And then we're going to sample some of this and some of that for 2-tile liquid lock. And there as well. For maintenance purposes. Good. Running this insulated pipe through here then is a big mistake. Can we run it differently? Could run it like so. Is definitely good enough. Let's empty out the reservoir completely. Good. I mean, this is good enough. Let's deconstruct simply. Good, we're not flowing now, but we will. Alright. And even insulated pipes we cannot have behind liquid locks, because they're going to take on the supercoolant temperature, and in this case the supercoolant is very cool. Then we could do something like branch this off, or bridge this over into a loop here, and if that loop is too hot, we're going to get rid of it, and that means we don't need that system here at all. But we could have both. Still, it's a waste of space. Huh. Time to renovate everything. How many cooling loops do we have? Hydrogen, oxygen, Saturn critter trap. But what if the oxygen temperature and the Saturn critter trap temperature would be the same? Oxygen, liquid oxygen minus, no, cannot. So yes, that is a third one. And then a fourth one is the base. Huh. Well, this is a lot of space wastage. I don't like it. Good. But that is good to know the dog is leaving. And that means we're also done. Good. But what we could do is, if the jump lock is here. Oh no. Then we don't have space. For another lock. For a vacuum in between. So we could jump into that. That is the dumbest thing. But, sure. Let's signify using gold. Why do I have this? This doesn't make any sense. It's nonsense. That's more reasonable. But we're gonna renovate anyhow. Good. Sample. Brush. Oh, what am I doing? Sample. Brush. Instant mop. Clean. Alright, so let's fill this with hydrogen. But yeah, this system is wonkered out. Got nothing here. Can enter from there. Different way. So if we have a little bit of oxygen here, we can already experiment with the door system. Yeah, we could experiment a little bit. Dog is back, but he's on a couch now. Ba-bum. This guy. Huh? Is that a camera? Yeah, it's looking at you. It's looking at you, little guy. What is the speed here? Good, so we could experiment, should we? With the door system, which is dumb. It is the dumbest system. Let's put it in since we started this. Good, we need to take the temperature here. You have a pump as well. Good. This is gone. Let's pump some. Insulated liquid pipe. We have dedicated power. Let's connect it. Oh, this connects straight. I do like. Alright. Now we're getting hydrogen in here, which is going to be very clean. And dedicated power to this pump as well. Maybe from down here this time. Good. Do have power, we have no liquid. It's not going to pump anywhere either. So some temporary liquid reservoirs. One for hydrogen, one for oxygen. Good. Plumbing insulated from insulation here. Good. And here the same. Oops. Well, we're running through. So like so. Good. Alright, this is the hydrogen and this is the oxygen. Right. Let's fill. Oxygen. Liquid oxygen here. Will this break the lock there? No. Good, it pumped a little bit. But no, I tried to. Good, we're at minus 50. When we're gonna liquefy? Condensation minus 183. So we're taking cool out of here because we're not good enough. Shipping utilities. Automation thermosensor. Right, automation wire. If the temperature here... Oops, what the heck is this? Mop me up. Clear floor. Doesn't clear the floor. Because it's stuck in the door. That suck off. Let's deconstruct here for a moment. Oh, we have to deconstruct the doors. For the game to register what we're trying to do. Good. And build it again. Where is the doors? Pom 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 pom. Let's not forget the automation should be in. Yes. So we're going to open the door if we're below... What was this? 180? 183. If we're below 186 would then be the number. This is something we can remember. 200 degrees? Possibly. Good. If we're below 200 degrees. And when is this going to freeze the liquid oxygen? Well, I do not know. Huh? If we're below minus 200 degrees, dude. And now we're taking out the cold. Temperature is different now. Cool me down. What is this? No power available. Because we're not hot enough, but we will be. Suppress. Good. We're running. This is gonna stay safe, hopefully. This is going to liquefy, and then we're gonna take it out. If we liquefy over here, it's not gonna be great pine. But since this is too big, we're gonna move everything up anyhow. In the end. Have a normal entrance there. And we take the liquid out. Into here then. Good. Alright, so are we cooling down? We are. Temperature plate is... Is it cooling down? I don't see anything happening. Cooling down should be more than heating up. Coolant is at minus 70. Coming in at minus 50. 73. So it takes a good while. But it's working. Oh, we're broken here. What happened? Oh, of course the crude oil melted down. Yeah. That makes a lot of sense. Mop. Good. Well, we're gonna have our supercoolant lock. I want this to spill. Oh man, what am I doing? Sample? Brush? Oh, that's a lot. But it's fine. If we're close here. Oh, what was this? Crude oil is here now again. That's so dirty. Sample. Fill. Good. Gas. Sample fill. Alright. Yeah, that messed with the temperature, I'm sure. But we cannot have cold chambers be sealed off using crude oil. That's a bad idea. Good. This chamber is at minus 67. This chamber is at minus 65. So what we're doing now is we're cooling down everything here. And that's why it's taken so long. But let's look at the coolant. Minus 82. Minus 83. Yeah, this is taking forever. That's alright. We have extra power from this. So we're only using like 350 power or so to cool this down. That's nominal. Steam is at 212 degrees. We can cool this down using a single steam turbine. That's good news. Definitely don't need to introduce extra heat. How much do we have saved here? That's good. That's a good amount. But this is how it could look, but this is not how it's gonna look. Because we're going to use the split off trick and to signify this for next time, because we're at the 3 hours mark and the dog is hiding again. I'm going to save that project for next time, but really quickly to demonstrate. This is minus 80 degrees now. So we would bridge this onto a different loop. And the other loop would eject its liquid into where? Could we zipper in here? I think the most reasonable thing would be zippering in here, because then we would have a constant flow. Liquid shut off. Good. Like so, simply. Except we're immediately bridging on, but we're not. We will not immediately bridge on, because we're taking it out from here, and then the free loop-de-loop will take a cold blob, and that is a fantastic system. Let's demonstrate. Constant flow, a loop, and this bridges onto the loop. And the direction, oops, we're bridging onto the loop because the loop is empty, and the direction is not clear. Yeah, that's bad. So we have to have this somewhere else. Good. Deconstruct. And the direction needs to be very clear. That means we need to have a bridge over there. And then we go this way and around. Good. Wonderful. That's how it's going to look. And if the temperature is too hot... Oh man, oh man. But the music is out, we have to stop. Good. If the temperature... What am I doing? Shut off is over here, and temperature sensor is right in front of it. Liquid pipe, a thermosensor. Good. Oops. That's how it's gonna look. Wonderful. We're gonna have automation as well. Real quick. And power comes from somewhere. Alright. So if the temperature is too cold, if it's not cold enough, we're going to eject it. Alright. So if we are too warm, like above 27 degrees, if we're above 27 degrees, we're going to eject it. If not, this loop will stay at its current temperature, which is quite cold currently. But that's alright, because we're going to configure this in an auction atmosphere which will be hot. And that is then the system. So this stays stable at minus 83 degrees, that loop. And if we're going to eject a blob, then we're going to get cooler liquid in. And as we can see, liquid is 95 degrees here. Let's speed this up. Good. And this is going to go all the way up to minus 250 or whatever I have configured here. 257. And then the hydrogen will liquefy. And if we're here too cold, the doors will open to oxygen liquefaction temperatures. But I think we're going to do the same system we have here over there, because that saves us a lot of space. And the door system is crude, let's be honest. And then I think that is good. Wonderful. That is then for next time. Renovate everything and use this loop system instead of the door system. Then we're going to save some space. This is going to be secondary loop, so we're going to have 4 different types of temperatures: liquid hydrogen, liquid oxygen, Saturn crater traps, and the base, 27 degrees or so. We can have these loops everywhere in the base. We can have as many temperatures as we want using this system, because it's the simple solution. Simply. It's simply simply the best. Anyway, thank you guys so much for watching. Thanks for chiming in. And don't forget my free wheel spin giveaway. I'm going to put the link up in chat. This is going to be there in the About page, in the 500 archives as well, or here on Twitch as well. Just click the link and register for free, and you're going to have the chance to win a PlayStation 5, but you're definitely going to win a free Steam game if your name is pulled from the lottery, and there's not many people competing against each other. I'm going to participate myself because I want that PlayStation 5. So on the 1st of every month is going to be this free wheel spin giveaway. But I'm going to stream tonight the New Vegas. And until then, thank you guys so much for watching again. And thanks for chiming in again. I'm going to see you then. Have a good day and a good night.